Hey guys, in this video I'm just going to go through a few examples of initial value problems for basic separable differential equations. So I'm assuming that you already kind of understand the basics of this. If you do not and you need a bigger explanation on that, I have a full lesson on this, and it's really not too long actually, but in this video I'm just going to go through these three initial value problems. So ideally you would kind of already know the basic idea behind this. So ways you can use this video: if there's a particular example you want to see, you can fast forward to it. Otherwise, you could always use this as a way to quiz yourself and then hit play when you're ready to see all the solutions. Okay, so let's get into this. So for this first one, I've got dy dx equals the square root of y, and then I've got this initial value condition. So separable equations. So the whole idea behind this is that you basically want to get your y's together and your x's together. And so you're going to basically do some algebraic manipulation to this to make that happen. So in this case, what I need to do is I'm going to have to bring this dx over to the other side, and then this square root of y, I'm going to bring it over here. So I'm going to multiply both sides by dx and then divide both sides by the square root of y. So the way that that's going to look, this will be 1 over the square root of y dy equals 1 dx. So there's your problem. And so, right, so you bring both of those to each side and then you integrate each side. So I kind of broke this down, like I said, in that lesson video. So if you want a more robust explanation, be sure to check that out. So just to make this a little bit easier on me, I like to always rewrite these in their rational exponent form. So I'm going to write this like this, and then I can go ahead and integrate. So this is 2y to the 1/2 equals x plus c. So it's just kind of the general habit that we put the plus c on the x side, and you only need the one c. And now I have to figure out what is c. So I figure out this c by using this initial value condition. Oops, sorry about that. Using this initial value condition. So this is actually telling me everything that I need to know. So it's telling me to plug in 0 for x, and it's saying for the y's plug in 4. So the way that this will look then, so I'll continue this on over here, this will be 2 times the square root of 4, oops, 2 times the square root of 4, equals 0 plus c, so I get 4 equals c. So then my answer, my final answer, the particular solution, is just restating this part, except now I plug in that particular c. So there's my particular solution in this case. And so that's it for that one. Okay, so moving on to the next one. So once again, it's the same idea, right? So I want to get the dx and the x together, and then I want to get the dy and the y together. So I basically need to manipulate this so that they kind of cross over sides. So on this side, I'm going to integrate y dx, and then on this side, I'm going to integrate x dx. So it actually works out to be something nice and straightforward. So if I integrate, this is 1/2 y squared, and then this is 1/2 x squared plus c. So again, that c just always happens to go on the x side. And now I have to use my initial value condition to figure out what my c is. So in this case, I'm going to plug in 2 for x and 6 for y. So if I do that, I get 1/2 6 squared equals 1/2 2 squared plus c. So this is 36 divided by 2. This is 4 divided by 2. So I get 18 equals 2 plus c. So my c equals 16. And so now I have 1/2 y squared equals 1/2 x squared plus 16, and I'm done. Okay, so now for the last one. So this one's a little bit trickier. So at first sight, when you look at this problem, so I've got dy dx equals 3x squared y squared minus y squared. This might not look like the y's are together, and what makes something separable is that you're supposed to be able to separate kind of the y part and the x part by multiplication. So just notice in the way that this is stated, these both have this same term of y squared. So I can actually factor out the y squared so that this becomes 3x squared minus 1. So I have to make this manipulation so that this will actually be separable. And then I want to divide this side by the y squared so that I can put the y's together and the y and the dy together. And then I'll bring this part over, so that's kind of what we want to put together. So this will become 1 over y squared dy equals 3x squared minus 1 dx. And so now this is when I want to integrate. So I get negative y to the negative first equals x cubed minus x plus c. And now I need to plug in once again my initial value condition. So this will be negative 1 over 1/2. And what is negative 1 over 1/2? I'm just going to write this out. That turns into just 2, negative 2. And then this is 0 cubed minus 0 plus c. So my c is equal to negative 2. So then my final answer will be negative 1 over y equals x cubed minus x minus 2. And so that would be my final answer for that one. And so that covers it for these examples then. So I have other examples of just finding general solutions. And like I said, I also have a video where I go through just the general idea behind this. So if you're looking for more, feel free to check those out. Otherwise, thanks for watching. I'll see you guys next time.